So we've got a diagram here with a large circle, a smaller circle, and a regular pentagon ABCDE. I'm already thinking the interior angle of a regular pentagon is 108. Not sure if that's useful, but let me just put it in. ABCD are pointing to a large circle. The pentagon has sides of length 8. Diagram is shaded such that the shaded area is equal to the unshaded area. Work out the radius of the smaller circle. Now, I'm just looking at this big radius here, and I can see this equilateral triangle that can be cut into a right angle triangle. We just take that out over here. So this length here is 4, that one there, half of the length DC. Now, because we've got a regular pentagon here, this angle here in the isosceles triangle would be 360 divided by 5, which is 72. I need half that from a right angled triangle, 36. Just draw that a bit bigger. This x is our unknown here. The radius, the opposite hypotenuse. So sine of an angle is equal to opposite over hypotenuse. Let's just make h the subject there by timesing both sides by h and dividing both sides by sine 36. So my radius of the big circle is equal to, I'll carry forward some decimal places here so I don't lose accuracy, 6.8052. So the area of the large circle, pi r squared, pi times 6.8052 squared. $145.4895. Let me just bring another diagram over so it's not too messy. So I'm also thinking, well, can I find the area of this isosceles triangle and times it by 5? Because it's made up of, like, if I split it up, it'd be 5 isosceles triangles, the same area. I know this angle here is 72, I worked that one out before. I know this length is 6.8052. I can use the sine rule for area, half AB sine C, half times 6.8052. $22.022. Okay, then I need to multiply this 22.022 by 5. Which gives me 110.11. So this is the area of the pentagon. Now, if I did the area of the big circle minus the area of the pentagon, you get like the shaded bit around the edge. So the area of the large circle minus the area of the pentagon. So that's like, it just changed the colour. So this represents like just these shaded bits here. So I know that 35.3795 plus pi r squared, because that's the area of the smaller circle, is equal to the pentagon minus pi r squared, because the unshaded area is just the pentagon minus the little circle. So I just need to make r the subject now. I'm going to add pi r squared to both sides, which gives me 2 pi r squared, and I'm going to subtract 35.3795 from both sides. I'm going to divide both sides by 2 pi. Square root both sides. Gives me 3 significant figures. R is 3.45.